Metrics are continuous measurements of a particular aspect of your system over time. This means that rather than logs, which are specific events, in other words, discrete data types, metrics are continuous, meaning they're constantly measuring some value. For example, here, if I move myself, you can see that we have a metric called DB statement latency. DB statement latency is a constant measurement of the latency of specific queries that have been issued against a database. What this means is that you have some questions when you have continuous values. For example, how often do you sample this data? Because you can't sample it all the time, otherwise you have an infinite data source. So it's very, very common to have metrics that are sampled every 30 or 60 seconds, 60 being the most common and a happy medium between data volume and between granularity and precision of your measurements. So the power of metrics is that they can give you really, really powerful key insights into what's happening in your system, and you can perform calculations on them. You can group them, you can average them, you can add them together, and much, much more. Metrics are also very, very high performance, meaning that you can query them over a really long period of time, and it'll still load really fast. So you can see here that we've done 7 days, and it's loaded nice and fast here. You can see this data is all coming together really cleanly, and what this means for your system is that you can get these really powerful historical views without the excessive costs associated with logs and traces of holding them for a really, really long time in most other platforms. Now, what this means for your metrics, the role they play in your stack is simple. Long-term historical reporting, up-to-date operational insights into what's happening in your system, for example, CPU and memory and much, much more, and latency, error rates. And finally, when you add those things together, they create a really clear numerical insight into what's happening in your system at any given time, whether it's now, whether it's over the past several months, whether it's over the past several years, if you want to hold on to the data for a really long time. And they work really nicely with this because the data can be queried over long periods of time really easily and really quickly and really cleanly. So you can see here that as we extend the query, it still loads nice and fast. Now, all of this adds up to make a really nice, really clear picture of your system in a purely numerical basis, very cost effective to store for a very long time, very high performance for long queries. One thing to be aware of when you're defining your metrics is cardinality. Now, you'll notice that each of these metrics have different labels on them. These different labels can have different values. For example, this is the actual statement itself, this is the service, this is the DBMS, and this is the source of that metric. Now, if you have some of these labels that have lots and lots and lots of different values, you have what we call in Coralogix lots of permutations. We'll explain this in more detail in a later video. Now, when you have lots of permutations, it can really slow down your system. If you're, for example, using Prometheus in your own infrastructure, it can make it really difficult to query your data because you have lots and lots of different values. So your metric solution is having to track lots and lots of different versions of this metric. We'll talk more about cardinality and dimensionality in later videos, but it's just something to be aware of when you're defining your metrics. So, quick recap, metrics are really powerful for both historical and operational data. They also give really powerful insights because they can be calculated on really easily using well-known languages like PromQL. In Coralogix, we use PromQL for all our metrics analysis because it's well understood, the documentation is really clear, and most of the industry is aware of that syntax.